Hi, I'm Eric from Alpha Power Solutions, and today we'll be talking about the difference between power factor and energy efficiency. Power factor is an expression of how efficiently a site uses the total power it draws from the grid. A good power factor of 0.95 means that the site draws very little reactive power from the grid because it has a functional power factor correction system. Every plant requires reactive power in order for electrical and electronic equipment to operate. But with power factor correction, you basically manufacture or generate most of the reactive power that the plant consumes. You generate it yourself on site with a power factor correction system so that it doesn't have to be drawn from the grid anymore. Now, what about energy efficiency? Energy efficiency is more to do about using equipment and technology that results in less energy being consumed to achieve the same output or result. For argument's sake, everybody's aware, for example, LED lights. They consume a fraction of the power that the old incandescent light bulbs were consuming, yet they produce similar amounts of lux or light intensity. It means that the LED lights are much more efficient, energy efficient than incandescent lights. That is now one example. You can also go to energy efficient motors, consume less power for the same work they can do. You've got variable speed drives that work very well in reducing electricity costs in certain applications. But it's not all about just the electricity. For example, upgrading the glazing of the windows to triple glazing or double glazing will have a significant impact on the air conditioning system or the electricity costs associated with the air conditioning system because you're leaking out less heat or allowing less heat to come into the building. So there are many more technologies and equipment that will help reduce your power usage without affecting the production of whatever the business is manufacturing. There is a myth where some people believe that power factor correction is installed to improve the efficiency of motors. That's not the case. Power factor correction cannot improve the efficiency of motor. But some people blame poor power factor for recent motor failures. So basically, the factory might experience a number of electrical motor failures, and then they think, it's because the power factor is poor. That's also not really the case. The difference between power factor and energy efficiency is not always understood by people who do not have an electrical background. If you only focus on improving the efficiency, it means using less kilowatt hours, and you don't focus on also optimizing the power factor of your plant and the associated maximum demand, you are leaving money on the table because the efficiency of equipment will have a significant impact on the kilowatt hours that are being consumed. But the power factor will have a big impact on the demand related to charging, which represent typically 50% of the total electricity bill. So ideally, you need to address both the energy efficiency of the site as well as the power factor of the whole electrical distribution system. There are a number of factors that influence the electricity bill, and one of them is the applicable tariff of the utility that's supplying plant with electricity, as well as winter and summer tariffs. Let me give you an example. If you had two identical factories, say one in Ekurhuleni, completely identical, and you have the one in Ekurhuleni and you have one in Mfuleni, which is Vandabel area, then the demand charge of the Mfuleni municipality will be approximately 4 times higher than the ones from Ekurhuleni. So the applicable tariffs are a key factor in determining what the electricity costs will be ultimately at the end of the month. If you operate longer working hours because you received a big order and instead of running one shift, you're running 2 shifts, That will significantly increase the kilowatt hours that the plant consumes, but will not necessarily increase the demand related charges. A site might have energy efficient equipment, but still have a poor power factor, and that results in higher electricity charges. And yeah, it comes to maximum demand charges. One of the other than improving power factor, the other big factor is avoiding switching on all the equipment at the same time over a period of 30 minutes, because your peak power usage in any 30-minute window during the month, that's what you will be built for. Do not switch on everything. Stagger the starting of machines over an hour or two if you can afford it. It's not always possible. Maybe all the machines need to be on at the same time in order for the factory to produce what it is producing. But where there's possibility to stagger the starting of machines, it should be really investigated. So a poor power factor typically affects the charges related to apparent and reactive power drawn from the grid. So I'm talking about maximum demand charges, network access charges, notified maximum demand charges, reactive power consumption, and in some cases, like in Zambia, power factor surcharges. Energy efficiency is related to reduction in the kilowatt hours by the equipment installed in the plant to achieve the same result. So it's two separate technologies or functions within the power usage environment. They're clearly distinct, and although they interact to some extent, they need to be treated separately. Well, the power factor can easily be determined from a load. Either the client has got that information, or we install what we call data loggers for a week or two on site, so that we can get the profile of the customer and we clearly see what the power factor of the plant is during peak load conditions. So that's pretty straightforward, and the savings can be guaranteed from a power factor correction intervention point of view. Now, a poor efficiency situation requires really a site visit to determine the opportunities that might exist in the plant to reduce active power usage. Some sort of an audit needs to be carried out. But the low-hanging fruit is mostly common sense items. Like, for example, and I mentioned this before, fixing air leaks, installing LED lights, installing timers, switching off used equipment, installing double or triple glazing, installing insulation material in office buildings, etc. So there's quite a lot of opportunities that can be implemented. Not all of them have attractive returns on investments. The trick is to find the ones that will pay for themselves as fast as possible. Once the client has got all the data of his power usage, like I mentioned before, having his own meter installed and having access to the data in fairly short interval, ideally within 30 seconds, but it's not always necessary. 15-minute intervals is also acceptable. Then they can start analyzing, and they should keep analyzing where power is used and where it's wasted. Once they've identified these opportunities, obviously they need to develop action plans, and these should be prioritizing the opportunities with the best cost-benefit ratio, and then set the targets and keep managing and monitoring performance of these actions. And then basically once a set of improvements has been implemented, you should keep on adding new actions so that you keep improving and implementing new solutions and technologies. So power factor correction is not a set and forget item. It obviously needs to be well designed initially, but it needs to be maintained. And like I've said many times before, the maintenance is actually quite simple. It's mostly about housekeeping, keeping things clean so that the equipment can keep operating. And then, sometimes also it requires upgrading because the business has added more machines and the initial equipment is no longer suitable. It's too small, so to say. The beauty of power factor correction system, and it's not that because you need a bigger system, you need to get rid of the existing system and put a bigger system. That's not necessary. In most instances, it's possible just to add additional power factor correction to the existing system. And I want to reiterate once again that energy efficiency saves power unit, talking about kilowatt hour. PFC saves on peak power use, peak power usage related costs. You can be efficient and still pay too much for your electricity that you consume due to excessive maximum demand. So don't guess, measure it so that you can implement the right solution. So power factor. Well, thanks for watching. If you found this helpful, please like and subscribe. There's a blog with more info linked in the description below. So if your business is losing money on hidden electricity costs, take our quick 3-minute assessment to find out. The link is also in the description below.